Hi, year 11s, this is Mr. Lim here again, and this is our 13th video on hydrocarbons. We're going to do the last part of addition reactions, so let's get started. All right, so we're going to be doing addition reactions again, and we're going to use this cool rule where we're going to go add some stuff to some alkenes or alkynes. All right, so let's have a look here. Let's have a look. So water and hydrogen halides can be added, can also be reactants during an addition reactions. All right, so remember addition reactions, you're breaking the double bond, you're going to add some stuff to the hydrocarbon. In the last video, we went through adding hydrogen gas, which is just adding two hydrogens, or adding a halogen gas or something, where it's adding two halogens, all right? But now we're adding water or hydrogen halide, and so this is the part where it's different. The molecule that's being added, the water of a hydrogen halide, is split into a hydrogen, and then either a hydroxide ion if you're using water, or a halogen if you're using a hydrogen halide, and then added to the alkene at the location of the double bond, which is exactly the same as the last addition reaction. So what that's saying is that, okay, let's take a water molecule here, H2O, which is in theory just a H, an O, and a H. So you're going to take this and you're going to split it that way, and you're going to add a hydrogen to one side and an OH to the other side, right? And then if you have a hydrogen halide, like HCl, which is just a H and a Cl, you're going to split this up again, and it's going to put a hydrogen on one and a chlorine on another, or a chloride on another, right? So that's the idea of the molecule is split and then added across the double bond. Because the two parts of the molecule being added are different, they can possibly form two different isomers. All right, so let's have a think about what happens here. So let's go add this to, oops, I don't want that. All right, let's go add this to a propene. All right, so 1, 2, 3, 4, 5, 6. Okay, so adding to a alkene, you break the double bond, okay, and turn it into a single bond, and then you end up having the two new bonds that can be formed across those two carbons there. Now, what's going to happen is that if we're dealing with the water one of them is going to be a hydrogen, one of them is going to be a hydroxide, okay, where that one there bonds to the oxygen in a single bond, and then the oxygen bonds to a hydrogen in another single bond. All right, so that's what it means by the two parts of the molecules that added are different. They can form two possible isomers. So this is one possible isomer, right? And then the other possible isomer is the other way around, where the OH is added to this one, and then the hydrogen is added to that one. Okay, so those are the two possible isomers that you can add because you're adding two different things across the double bond. If you're talking about the halogen, you can, or the hydrohalide, you can either have this where it's a 2-chloropropane, or alternatively, if you swap it around, it can be a 1-chloropropane. Okay, those are the two isomers that you can create. However, in reality, the two parts of the molecule add in a manner where the hydrogen always bonds to the carbon which has more hydrogens, right? So back to this example here where we just do the hydrogen halide, right? Let's just call this number one. Oops, that's what I want. Let's call this number 1 carbon, number 2 carbon, number 3 carbon. So the number 1 carbon is bonded to two hydrogens here, and the number 2 carbon is bonded to one hydrogen here. Okay, so the hydrogen from the hydrogen and the chloride is going to bond to the carbon which has more hydrogens, right? Which happens to be carbon number 1. So carbon number 1 will get the hydrogen. Oops, let's put that in red. And carbon number 2 is going to get the chlorine. All right, and so it's predominantly going to form 2-chloropropane, right, rather than 1-chloropropane. Okay, so that's how it's going to be added to it, and it's always going to form in a majority, or which is almost all of it, in that form, right? If the two carbons happen to have equal amounts of hydrogens, then the hydrogen and the other parts are added randomly and evenly to the two things. So say, for instance, this started as an alkene again, but instead of it just being a normal alkene, it had a chlorine there already added to it, which means that there was a hydrogen here and a hydrogen here. Right, so this is 1-chloropropene. Then we add something to it. We break that apart. We have the 2 new bonds that are able, all right, to take stuff in. And then you'll notice that carbon 1 and carbon 2, where the stuff is being added, they have equal amounts of hydrogens. They both have 1, so therefore it's going to randomly allocate the hydrogen and the chlorine to those things there. So sometimes it's going to be this, and the other times it's going to be the other way around, and it's going to be random and roughly even. But generally, you'll get a question where it's clear to see which side you should be adding it to, where you should be adding it to the side that has more hydrogens to it. Okay, this way here. Okay, so the addition of water produces an organic molecule called an alcohol, which you will learn to name next year, but you just have an idea that the hydrogen and the hydroxide get added to it. And then the addition of a hydrogen halides produce an alkyl halide, which is what you've got over here, an alkyl halide, the chloropropane. Okay, so that's fairly straightforward. Okay, and so that's it. And now let's go on to some other stuff. Adios.